So hello, good day. So today we have this question. So in this question we are the question says a rectangular page contains 24 square inches of prints, the printing area. The margin at the top and bottom of the page there to be 1.5 inches, and the margin at the left and right to be 1 inch rather. Now what should be the dimension of the page? um so that the least amount of paper is used. Okay, now this is the paper. We have a paper here. So on this paper, the print page, the page that needs to be where the printing will be, is 24 square inch. Hmm? So this is the page where the printing part will be. Now we are told that the top and bottom each is 1.5 inch. Also this one 1.5 inch. Okay, then the top and the bottom, that one is 1 inch. The left and right 1 inch. So this is the left and the right. Okay, this is 1 inch, this is 1 inch. So let's call this distance from here to here, let's call it x. Okay, then from here to here, let's call it y. Okay, so this is the description of this question here. So now the question asked here is that what should be the dimension of the page so that the least amount of paper is used? The least amount. So whenever we hear things like the least amounts, the most amounts, the maximum, the minimum, the optimum. So whenever we hear things like that, we know we are dealing with maximum and minimum points, right? This means we need to find the dimension with respect to one of the area, or it could be area, it could be volume, it could be whatever it is given with respect to a particular variable. So normally we'll have two variables, but in the question, something will be given in such a way that we'll have to replace one of the variable with the in terms of the other, and it will now be an expression of that particular parameter with respect to one of the dimensions. Okay. So here now we see that from here to here, the dimension given here is x times y. That is area of the printing parts, the prints, right? The area of the prints. So let's call this A is equal to x times y. Okay, and of course it's given as 24. It's given as 24, right? What about the entire area? The entire area. So for this area, this entire length from here to here is going to be 1.5 plus 1.5. That is 3, and plus x. So that will be the dimension of this one. 1 plus 1, that will be 2, plus y, that will be dimension of this one. Okay? So the area, total area, so that will be x plus 3 times y plus 2. Okay, so this is the major thing we want to do here. So now this particular area, which is A total, is what? X plus 3 then y plus 2. But we have this equation that can help us make this one have one variable, that is be expressed in terms of one variable. So this particular equation will enable us to replace this y or x, any of the two, with whatever we get from here, right? So if this one is equation 1, from 1, y is equals to 3 all over, I mean 24 over x, right? We now substitute this in this equation. So we say substitute 24 all over x in, let's call this one equation 2. So a total will now become x plus 3. Instead of writing y, we now have 24 all over x plus 2. Okay? So we have been able to express this in terms of just one variable. Then they say the least amount, then we'll now do what? Find the ADX of this one. Yes, we find the ADX of this, and once we get it, we equate it to 0, because to get the least amount and to know whether it is the least amount, we just find the 2xd, the 2a, the x squared. So once we find out, if it gives us positive, we know it is minimum. If it is negative, it is maximum, right? Okay. So now let's expand this. What are we going to get? Expanding this, we have x times 24, that will be what? 24. Then x times 2, that will be 2x. 3 times 24, so that will be 72 all over x. And 3 times 2, that will be 6. 24 plus 6, that's 30, right? That's 30, right? Let's call this one 30. Right? So let's say we have 30 to x 72 over x, right? So now that we have this, we now want to find the 80, the x. So the a total dx, that was differentiating this will become 2. And this is the same thing as 72 x raised to the power minus 1, right? So if we use this to multiply this, that will be minus 72. Then x minus 1 from here, that will be minus 2. Right? So if we equate this to 0, what's going to happen? So that's going to be what? 72 all over x squared is equals to 2. So which means x squared will be what? If this comes here, that will be 72 all over 2. And that will be what? 36, right? So x will become square root of 36. And x will become plus or minus 6. But we are going to take only the positive part because we are dealing with real situation, and the dimension must be positive. So we take only the real part, which is x is equals to 6. Right? So now that we have x to be 6, what about the 80 squared, the 280, the x squared? What is it going to be? If you differentiate this further, so this minus times minus, that will be plus. So 72 times 2, that will be 144. Then x raised to the power minus 3. So this is the same thing as 144 all over x cubed. You know, if you put 6 here, it's going to be positive. So which is minimum? Right? It shows that it's minimum, right? So which means for the least amount, that's for this one. So x is equal to 6 in that situation. So then also, what is the dimension that will give us? So we just need to find y. And what is y? Y is same thing as what? 24 over x. So y is going to be 24 all over 6. And that's 4. So the dimension is going to be x plus 3 times y plus 2. And that will be what? X is what? 6. So that will be what? 6 plus 3, that will be 9. Then the dimension y is what? 4. 4 plus 2, that's 6. Okay, so this is the dimension. Okay, so this is the dimension. So dimension is what? 9 times 6 square inches. Okay, square inches. Okay, so that's it. Thank you.